Hello friends, today we are going to see integration by parts. Okay, if u and v both are functions of x or both are integrable functions of x, then the integration of u into v dx, that means product of u into v. Okay, that rule is known as bipart rule, and that rule is as integration u into v dx is equal to, or integration first term into second term dx is equal to first term as it is into integration of second term minus integration derivative of first term, that means derivative of u, into integration of second, okay, dx. So this rule is known as bipart rule or product rule for the integration. Okay, integration u into v dx is equal to u integration v dx minus integration derivative of u integration of v dx. Okay, so this is product rule of differentiation, or this rule is known as that is the uh, bipart rule of the integration. Okay, in this rule, to choose the first function, that is first function means u and second function means v. So to choose first term and second term, or first function and second term, there is no any general rule, or there is no any specific rule to choose first function and second function. So here we have to choose this u and v, that is u as a first function and v as a second function. That let's just keep in mind that Liet rule. Okay, Liate. Okay, just keep in mind that this Liet rule, Liate, this L in this word Liet is it means that the logarithmic function. Okay, L means logarithmic function, and then this I means the inverse trigonometric function. Okay, inverse trigonometric functions. Okay, or this L means logarithmic functions such as then log x, or log of some 1 plus x, or some log of some other terms. Okay, then this I stands for inverse trigonometric functions. That means, for example, sine inverse x, cos inverse x, or tan inverse x, and so on. Okay, then this a means the algebraic functions. Okay, a means algebraic functions, and for example, algebraic function means x square, or x cube, or x raised to any term. Okay, that functions are considered as a algebraic functions. Then the t stands for the trigonometric functions. Okay, any trigonometric function, that is sin x, cos x. Here I means inverse trigonometric, that is sin inverse, cos inverse, tan inverse, and this t means only trigonometric functions, that is sin x, cos x, tan x, sec x, or cosec x, anyone. Then and last, that e means exponential functions. Exponential means, for example, e raised to x, a raised to x, etc. Okay, so this type of functions are algebraic functions. So in this product rule, or in this bipart rule, we just have to take first function as a and as well as second function. So we consider this Liet rule in this case, and Liet means, or in this word Liet, the L stands for logarithmic function, that I stands for inverse trigonometric function, a means algebraic functions, and then t means trigonometric, and then e means exponential. Okay, in this sequence we choose the function u and v. For example, our integration have x into some sin x. So we take which first function as a okay, this x is algebraic functions, and this sin x means trigonometric function, and in our Liet rule a is first, then t. So we take first functions as a x and take second function as a t. Okay. Also, suppose we have I is equal to integration x into sine inverse x dx. Then in this case our x that means algebraic function, and this t on this sine inverse x that means inverse trigonometric function, and in our Lie rule I is first then a. Okay, so take first function as the sine inverse x and second as the x. So we take I is equal to integration sine inverse x into x dx, and then evaluate by using that product rule formula. Okay, so just we have to use this trick to solve any uh, type of integration that involve term multiplication of that two terms. Okay, so let us see examples based on this bipart rule. First example, evaluate integration x into e raised to x dx. Okay, so let I is equal to integration x e raised to x dx. Okay, here you can check this x is algebraic function, as well as this e raised to x. E raised to x means the exponential functions. Okay, exponential function. And in our Liet rule or LIATE rule, the a is okay, a is first then e. So we take first function as a x and take second function as a e raised to x. So our integration becomes I is equal to x e raised to x dx. We have to use the bipart rule here. Taking first function means taking u is equal to x, and second function, that is v is equal to e raised to x. Okay, because x is algebraic function and e raised to x is exponential functions. Okay, so we have to take in this way. So we have to take first function as algebraic, then exponential. So and our bipart rule is integration of u into v dx is equal to u integration v dx minus integration into derivative of u into integration of v dx. Okay, whole term multiply by also dx. So use this rule to evaluate this integration. So we get okay, let u is equal to x and v is equal to e raised to x in this formula. So what is bipart rule? First term as it is, that means x as it is, into integration of second term, that means integration of e raised to x dx, then minus integration in bracket derivative of first term means derivative of x. Okay, into integration of second term means integration e raised to x dx, and whole bracket complete into also dx. This dx is for this integration, and this dx for this integration. Okay, now our integration becomes x into integration of e raised to x. We know that integration of e raised to x is again e raised to x. Okay, minus integration, first we solve this square bracketed term. Okay, so derivative of x with respect to x, that is 1. Okay, and 1 into integration of e raised to x. Integration of e raised to x is also e raised to x, and e raised to x into 1, that is e raised to x. Okay, and into dx. So our integration becomes x e raised to x minus integration of e raised to x dx, and that gives x e raised to x as it is, minus we know that integration of e raised to x is e raised to x. Okay, and then plus constant of integration c. After evaluating all integration, we take constant of integration c in last step. So our answer for integration of x into e raised to x dx is equal to, we can take e raised to x as a common. Okay, so e raised to x into x minus 1 plus constant c. So this is our integration or final answer for this integration. Okay, now let us see second example. I is equal to integration x into sec square x dx. First of all, this x is algebraic function, and this sec square x means that is trigonometric function. And in our Liet rule, we can take first as a algebraic and then trigonometric. So here our first function is x and second function is sec square x, or our u is equal to x and v is equal to sec square x in bipart rule. And we know that the bipart rule, or that is product rule for integration, u into v dx is equal to first term as it is integration of second term minus integration into bracket the derivative of first term into integration of second term dx. Okay, so we can use this rule here also. So our u is equal to x and v is equal to sec square x in this bipart rule. Okay, so our integration becomes integration x sec square x dx is equal to first term as it is integration of second term, okay, minus integration bracket into derivative of first term. First term means x into integration of second term. Second term means integration of sec square x dx. This bracket complete, and also dx for this integration. Okay, so that becomes x as it is into, we know that integration of sec square x is tan x minus, okay, integration of sec square x dx is tan x, and minus integration derivative of x, derivative of x with respect to x is 1, okay, into integration of sec square x dx, and we know that integration of sec square x is tan x, okay, into dx. So our integration becomes x tan x minus 1 into tan x, that is integration of tan x dx. Okay, so our integration becomes x tan x minus integration of tan x dx. We know that the integration of tan x dx is log of mod of sec x, or log of sec x. Okay, and last finally plus constant c. So this is our final answer for integration of x into sec square x dx, that is x into tan x minus log of sec x plus c. Okay, now our next example is I is equal to integration of log of x dx. Okay, here you can see only one term is present, that is log x. Okay, and no any term multiply this term, but we can take that is equal to integration of log x. Our log x is logarithmic term, and in our Liet rule logarithmic term is first, so we take just log x into 1 dx. Okay, we take first term as a log x and second term is a 1. 1 is constant, and constant means that is algebraic function. Okay, so we can take some adjustment here. Log x, integration of log x is equal to integration of log x into 1 dx, because log x into 1 is again log x. So, and then use bipart rule or product rule for integration, and our integration becomes first term is log x, second term is 1. So integration of u into v dx says u integration v dx minus integration derivative of u into integration of v dx and again whole dx. So our integration becomes that is equal to first term that is log x into integration of second term means integration of 1 dx minus integration derivative of first term, and first term is log x, okay, into integration of second term, that is 1 dx and whole dx. Okay, so that is equal to log x as it is into integration of 1 dx, and we know that integration of 1 is x minus integration derivative of log x, and we know that derivative of log x is 1 upon x, also into integration of 1 dx, and integration of 1 dx is x. Okay, and this dx remains. So that is equal to log x into x, that is x log x. Okay, log x into x, that is x log x minus here x get cancelled, so only integration 1 dx remains, and that is equal to x log of x minus integration of 1 dx is again x, and then plus constant of integration c. You can take x as a common also, so x into log of x minus 1. Okay, we have taken x as a common, so plus constant c. So this is integration of log x. Integration of log x is x into log x minus 1 plus constant c. Okay, now let us see another example. I is equal to integration x into log x dx. Okay, here this x is algebraic function, and the log x means that is our uh, logarithmic function. Okay, so use Liet rule here. Okay, LIATE, that means our logarithmic term is first, and then x means algebraic, then second term should be algebraic. So here we can take integration log x first and then into x dx. Okay, we have to take first term as a log x and then second term as a x using this Liet rule for product rule integration. Okay, so use here product rule or by part rule, and he says first term as it is, that means log x as it is, integration of second term minus integration into the bracket derivative of first term. Okay, and what is first term? First term is log x, that means derivative of log x into integration of second term dx. Okay, so that is equal to log x as it is into integration of x. Integration of x is x square upon 2 minus integration into the bracket derivative of log x, and derivative of log x is 1 upon x into integration of x, that is x square upon 2. Okay, and dx. So our integration becomes log x into this x square upon 2, that is x square log x upon 2. Okay, minus integration here this x and 1x from numerator is cancelled, so only x by 2 remains. Okay, so that is equal to x square log x upon 2 minus this 2 in denominator is constant, so take 1 by 2 as a common, and only in integration x remains, and we know that integration of x is x square upon 2. So our answer is x square log of x upon 2 minus 1 by 2 into integration of x is x square upon 2. Okay, and then finally plus constant of integration, that is c, and is equal to x square log of x upon 2 minus here x square into 1, that is x square upon 2 to the 4, or also you can take x square upon 2 as a common, so take x square upon 2 as a common, and in other terms, that is x square upon 2 is common, means only log x is in first term, and minus x square upon 2 is common, so only 1 by 2 remains in second term. So this is final answer, or you can consider this as also final answer of integration of x into log of x. So in this way, or using this Liet rule and by part rule, you can solve the integration of the form, or integration of the form integration u into v dx, or product rule. Okay, some problems for your homework. Okay, first problem for homework is I is equal to integration x into sine x dx. Okay, in this example this x is algebraic and this sine x is trigonometric, and using Liet rule you can take first function as a algebraic and then trigonometric, that means this is first function and this is second function, so use as a given. And then second example, I is equal to integration x into tan inverse x. Okay, this in this example x is algebraic and tan inverse is inverse, that means here by using Liet rule first is I means inverse trigonometric and then algebraic, that means this is first function and this is second function. Okay, and third example for you, that is I is equal to integration of tan inverse x dx. Okay, so here no any other function multiplied to tan inverse, so you can take that is equal to integration tan inverse x into 1 dx. Okay, this one is algebraic and this is inverse trigonometric, so this is first function and this is second function. Okay, and also answers for all examples are answer of first example is, that is answer of x into sin x, integration of x into sin x, that is minus x into cos of x plus sin x plus c. Okay, answer for second homework problem is sum x square upon 1 upon sum x square plus 1 upon 2 into tan inverse x minus x by 2 plus c, and the answer for last example is x into tan inverse x minus 1 by 2 into log of 1 plus x square plus c. Okay, so this is the end of our fourth chapter, that is integration or methods of integration. Okay, thank you.